In this video, I'll be finding the discontinuities of the following function f and classifying their types. The types of discontinuities of functions can include removable, infinite, and jump discontinuities. If you like, you can go ahead and pause the video and have a go at the problem yourself before seeing the solution. Okay, so let's have a look at the solution. What we can see is f is continuous in all these regions. So we have when x is less than 5, which is over here, when x less than -5, I mean, so that's over here. And we also have -5 less than x less than -1. It's also continuous. We also have -1 less than x less than 2. So it's continuous in this area over here. It's also continuous between 2 and 3 here, and it's also continuous when x is greater than 3. However, f is discontinuous when x is equal to -5, and we have a jump discontinuity at x equals -5. This is because if you look at x equals -5, from the left we see the function goes like this, but from the right the function goes like this, and this means the limit of the function from the left approaches here, but the limit from the right approaches here. So since the limits from the left hand side and right hand side are not the same, this means the function is not continuous at x equals -5, and this is called a jump discontinuity because we have different limits. Now if we look at x equals -1, we also have a discontinuity, and this time it's a removable discontinuity. This is because we have a hole here at x equals -1, and we see the value of f at -1 is over down here. But if we just move this point back here to fill in the hole, then the function will become continuous. This is the reason it's called a removable discontinuity, because if we just change this function value back to where this hole is over here, then it will be continuous at x equals -1. And now if we have a look at x equals 2, you'll see we have an infinite discontinuity, and this is because the function approaches infinity when x approaches 2 from the left, and from the right we see as x approaches 2 from the right, it goes towards -infinity. So we have x equals 2 as an asymptote. Since we have this asymptote of x equals 2, it's called an infinite discontinuity because the function limits to plus and minus infinity from each direction. And finally, we look at x equals 3, where we again have a jump discontinuity. So similar to earlier, at x equals 3, the left-hand limit is up here. So we approach this limit as x approaches 3 from the left, but from the right, we approach a different limit over here. This is the reason we have a jump discontinuity at x equals 3. This classifies all discontinuities of the function f. So this completes the solution to this problem. Okay, so hope you enjoyed this video. Thanks for watching, and I'll see you next time.